Okay, so now let's discuss the actual steps of the glycolysis process. So the glycolysis process, we're starting with glucose. We have discussed the basics in the previous video. So what will happen in the glycolysis phase? See guys, this glycolysis phase, it is divided mainly into two phases. One is called as the investment phase and the other is called as the payoff phase. Now what is the difference between this investment phase and the payoff phase? See, if you want to start a business, then you have to invest something. You have to invest money, you have to invest energy to start a business, right? Then only you will be getting the return. The same way, in the process of glycolysis, there will be some sort of investment, and that investment is nothing but it is the investment of ATP, right? So we'll see all these things in the steps. So let's see. So this glucose molecule, in this glucose molecule, one inorganic phosphate will be added. And how this inorganic phosphate will be added, or from where this inorganic phosphate will come? In the presence of an enzyme called hexokinase, or phosphorylase, and ATP, that is adenosine triphosphate, will be broken down into ADP and inorganic phosphate, and this inorganic phosphate will be added with glucose, and what will form? Glucose 6-phosphate. Glucose 6-phosphate means, it doesn't mean that there are 6 phosphorus in the glucose molecule. It means that in the 6 carbon, that means in the 6 number carbon of the glucose molecule, a phosphate group is present. Now this glucose 6-phosphate, in the presence of an enzyme called isomerase, it will get converted into its own isomer, and we know that the isomer of glucose is nothing but it is the fructose. So this glucose 6-phosphate will get converted into fructose 6-phosphate. What is the difference between glucose and fructose? Yes, the glucose is an aldose sugar, polyhydroxy aldose sugar. That means the aldehyde group is present in the glucose molecule, and fructose, it is a ketose sugar. That means the ketone group is present in this fructose molecule. Now this fructose 6-phosphate, again in the presence of an enzyme called hexokinase or phosphorylase will get convert and ATP will be broken down into ADP and inorganic phosphate, and again this inorganic phosphate will be added to fructose 6-phosphate, and fructose 6-phosphate, because there will be now 2 phosphorus, it will get converted into fructose 1,6 biphosphate or diphosphate, whatever you say. It gets converted into fructose 1,6 biphosphate. That means that carbon number 1 and carbon number 6, they are 2 phosphate group. Now this fructose molecule, you know that it is a 6 carbon compound. The formula of glucose is C6H12O6, right? Okay, C6H12O6. It is same with the glucose. So this fructose, which is a 6 carbon compound, in the presence of an enzyme called aldolase, this 6 carbon compound will break down into 2 compounds of having 3 carbon each. That means this fructose 1,6 biphosphate will be now broken down into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Okay, sorry guys, I am a little bit unwell. Dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, and these dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, both are isomer of each other. That means both can get converted from one form to another. Okay, both are isomer of each other. So both these compounds, they will be involving in the further steps, but first of all we will consider the first compound. Okay, or first of all we will consider this first compound, that is glyceraldehyde 3-phosphate. That means what will happen with this glyceraldehyde 3-phosphate, then we will see what will happen with dihydroxyacetone phosphate. So this glyceraldehyde 3-phosphate, this you can also okay, call it as phosphoglyceraldehyde. And glyceraldehyde 3-phosphate is having one phosphorus group at carbon number 3. From its name only you can see that it is an aldehyde, okay, glyceraldehyde or phosphoglyceraldehyde. So this aldehyde molecule will now be undergoing oxidation, and we know that whenever an aldehyde undergoes oxidation, it will get converted into acid. That means this aldehyde molecule will be now converted into acid, and that acid is nothing but it is phosphoglyceric acid or phosphoglycerate. But we know that whenever something will get oxidized, something will get reduced because it is a redox reaction. So what will get reduced here? NAD, that is nicotinamide adenine dinucleotide. NAD will get converted into NAD plus will get converted to NADH2, right? So this will get reduced, and an inorganic phosphorus will be added at this particular step. But this inorganic phosphorus which is being added, it is not coming from ATP, it is coming from an inorganic source. It is not coming from ATP, it is coming from an inorganic source, and this glyceraldehyde 3-phosphate will get converted into 1,3 biphospoglycerate. 1,3 biphospoglycerate. Now you see, so that means at carbon number 1 and carbon number 3 there are two phosphorus group, and this is biphospoglycerate, or you can also write it as phosphoglyceric acid. That means this aldehyde molecule has converted into acid. Now from there are two phosphorus in this particular molecule. One phosphorus from this molecule will come out, and this phosphorus which will come out, it will combine with ADP. So this is the phosphorus which has come out from this molecule. So this is the phosphorus which is coming out from this molecule, and this phosphorus which has come out from this molecule, it has combined with ADP and it is now forming ATP. So you can see that in the previous step, that means in the first two previous steps, the ATP molecule was being used, but now you can see that the ATP molecule is getting generated, or the ATP molecule, we are getting the ATP molecule. Okay, I will explain these steps in the, okay, I will explain how this ATP is will be used up in the further reactions. Okay, now this 1,3 biphosphoglycerate, okay, 1,3 from the 1,3 biphosphoglycerate, where two phosphorus group is present, one inorganic phosphorus has come out, and this inorganic phosphorus has combined with ADP, and we are getting ATP molecule. Now see, now one inorganic phosphorus has come out, so now this compound will be 3-phosphoglycerate. That means at carbon number 3, one phosphorus group is present. Now in the presence of an enzyme called phosphoglycerate mutase, the phosphorus group will be shifted. That means at carbon number 3 phosphorus group is present, so now this phosphorus group will be shifted, and this compound will be 2-phosphoglycerate. That means now the phosphorus group is present at carbon number 2. Okay, now in the presence of an enzyme called enolase, these 2-phosphoglycerate will convert into phosphoenol pyruvate. So in the presence of an enzyme called enolase, 2-phosphoglycerate is converted into phosphoenol pyruvate. In the phosphoenol pyruvate, you can see that one phosphorus group is present. Now this phosphorus group will again come out. So when this phosphorus group will come out, it will combine with ADP. So this is the inorganic phosphorus which has come out from the phosphoenol pyruvate, and we'll get an ATP molecule. Okay, we'll get an ATP molecule, and finally phosphoenol pyruvate will convert into what? Pyruvic acid. So we have got one pyruvic acid. But in the reaction, we have written that glucose, glucose, it breaks down into 2 pyruvic acid molecule. Okay, this is the glycolysis step, but here we are getting only 1 pyruvic acid. Okay, now you see, we are getting 1 pyruvic acid from 1 glyceraldehyde 3-phosphate, but I told that this fructose 1,6 biphosphate in the presence of an enzyme called aldolase, it will be broken down into 2 compounds which will be having 3 carbon each. right? One is dihydroxyacetone phosphate and one is glyceraldehyde 3-phosphate. We have discussed what will happen with the glyceraldehyde 3-phosphate, but there is dihydroxyacetone phosphate. So this dihydroxyacetone phosphate will get converted into glyceraldehyde 3-phosphate, and again these reactions will continue. Let me explain once. I have discussed about what will happen with glyceraldehyde 3-phosphate and how we will get one pyruvic acid, but we have not considered the dihydroxyacetone phosphate. Now what will happen with this dihydroxyacetone phosphate? This dihydroxyacetone phosphate will convert into glyceraldehyde 3-phosphate, and again these reactions will continue for once. That means we will again get one more pyruvic acid, right? So that's how we will be obtaining 2 pyruvic acid, and again in these reactions we will be getting 2 ATPs more. So if you see that how many ATPs are, okay, now you see, so these are the steps where the ATP was invested. So therefore we'll call it as the investment phase. Here the ATP was getting invested, investment phase, and here in these steps you can see that the ATPs are generated. So therefore we'll be calling it as payoff phase. Payoff phase. Okay. Now if you see that how what is the gain of ATP. Okay. Now before that, let me tell you once that this NADH2 that was being produced during the reduction process, okay, this NADH2, it is worth 3 ATP. It is worth 3 ATP. Now what is worth 3 ATP means? Say for example, if you take a check, okay, if you take a check, and in the check if I write you 100 rupees, then is there okay, is there any value of that 100 rupees or not? Definitely there is a value of that 100 rupees in the check. But if you go to the this local retailers or local shop to buy something, say for example of 100 rupees, say for example if you want to buy a chocolate, and if you go and okay, pay that check, then the retailer might not accept that check directly. But if you go to the bank and if you okay, deliver that check to the okay, this banker, then he will be giving you 100 rupees. That means this check which I where I have written 100 rupees, it will be having some sort of value. It will be having 100 rupees value. So this NADH2, this NADH2 you cannot use directly. Okay, it is not directly used, but from this NADH2, in the last step of the aerobic respiration, that is in the oxidative phosphorylation, we will be getting 3 ATP, right? That in the last step, not now, not directly now, but in the last step. This NADH2 first of all will okay, it is now produced in the cytoplasm. It will be moved to the mitochondria, and finally in the last step, that is in the oxidative phosphorylation, from NADH2, 1 NADH2, 3 ATP is obtained. Therefore we have written here it is worth 3 ATP. Okay, now let's calculate that how many ATP are actually produced in the okay, this glycolysis step. You can see that. So if you calculate the this net ATPs that are produced, so 2 ATPs are produced from 1 glyceraldehyde 3-phosphate, but I told that dihydroxyacetone phosphate will convert into glyceraldehyde 3-phosphate, and again these reactions will continue. So that means total 4 ATPs. So ATP produced are 4 ATP. ATP produced are 4 ATP. ATP produced are 4 ATP. But if you see that ATP, how many ATPs are getting used? So if you see the used ATP, then 1 ATP is getting used when glucose is converted to glucose 6-phosphate, and 1 ATP is used when fructose 6-phosphate get converted to fructose 1, so it's biphosphate. That means 2 ATPs are used. So if you calculate the total, then it will come 2 ATP. So that means the gross ATP that is formed is 2 ATP. But if you see the net ATP that is formed, net ATP, so net ATP means, okay, here I told that NADH2 will be produced, and 1 NADH2 is worth 3 ATP. It is not producing ATP now, but in the last step it will be producing ATP. So if you consider those ATPs which will be produced by NADH2 or from which will obtain from NADH2, then how much ATP will come?